Okay, hello everybody. We'll start today playing with SpriteKit, and to do that, we'll create our first game. So we'll start with creating new Xcode project, and this time it should be game. Right? Last time we were playing with UIKit, and we are building our anagram game using UIKit. This time we are starting with game, and we have to select SpriteKit. Right? There are other options. If you check, you have SceneKit, you have OpenGL, you have Metal, different engines for different types of games. We'll discuss differences during the lecture. Today we are starting with SpriteKit. And we'll start playing with a simple Pong game. Right? So my game will be called Pong. Organization name, organization identifier, that's your choice, whatever you like. Language, Swift. I'm choosing iPhone just for simplicity. Next. And we are saving it in our folder. Create. What do we have here? We'll see that our project looks very similar. There are two new things that appear in the project structure. One of them is GameScene.swift. The other one is GameScene.sks. GameScene.sks is a file where you can graphically build your scene using different types of nodes that are accessible here on the bottom. You have different nodes, different fields, different effects that you can do, including actions and stuff, right? So that's visual. It's similar, the way how you build it is similar to the way how you build the storyboard. GameScene.swift, this is implementation of our game. And today we'll be mostly playing in here. We'll be mostly adding nodes and maintaining them inside the SpriteKit, inside the game scene file. So we'll use code, and we'll create all the nodes using code. Now, if you run the game as it is without any changes, let's try. What happens? First, it runs this huge emulator. I didn't change the size, but it runs the sample code, and sample code basically gives you the label, hello world. If you tap, it starts adding nodes, those rotating planes. That's the default when you create new project. Right? Also, a default setting is to show you the number of nodes and the frame rate. Okay, that's something that we don't want. So what we'll do, we'll clean the code that is there. You remove all the code from touches began and from did move to view. Okay, let's talk about those methods that we have. The first one, did move to view. This is the method that is called whenever the scene is pulled into the view, is displayed by the game view. Right? So that's the first thing called in your game. That's a good place to initialize anything that you have in your game. Touches began, you know this method from UIKit. This is one of the methods, one of 4 methods that allow you to deal with touch events, right? Touches began, touches moved, touches ended, and touches canceled. 4 methods that you can implement to recognize different behaviors in terms of events, touch events, right? And update is part of the game loop, and this method is called before each frame is rendered, right? So this is a place where you can update your the logic of the game should update the state for all objects that are not affected by touch events. Right? So things like objects that move automatically will be updated here. What do we need for Pong? Well, for Pong, we need 2 paddles, right, and the ball. So let's start with the paddle. So let's define our paddle 1. This paddle 1 will be SK sprite code. Of course, it should be a variable. And it will be optional. Our paddle 2 will be also SK sprite node. And the last one, ball, to use different things, to show you different things, this one will be SK shape node, also optional. Now we'll initialize them in the move to view. We can do that, or we can create a separate method to instantiate them. Right? It will be easier for us to create a method that will create a paddle. So I will separate this, and I will create a function create paddle that will return SK sprite node. Now the question is, what do we need to create a paddle? Do we need any parameters? Well, yeah, it depends, right? If we want to hard code width and height and position, we don't need anything. If we want to create a method that is flexible, that allows you to create any kind of paddle, then probably having height, CG float, width, CG float, and position is CG point. You can also replace height and width with size. There is a type called CG size that you can use to pass height and width as one parameter, right? Okay, so let's start. Let paddle be equal to SK sprite node. Now, we don't have any image, so we could use image to create this. What we want to do, we want to just create a rectangle of a specific size. So there is a constructor that allows you to pass a color and a size. UI color, let's go with black. You can play with colors later. And CG size, we have width and height. we have our paddle. This paddle will be returned from this function. But that's not the end, right? That's just a rectangle on the screen. We want this paddle to be able to interact with environment. And we want this paddle to be in a specific position, right? Where do we want to put this paddle? Well, paddle.position will be equal to position. If we call this method right now in did move to view, so we'll say paddle1 equals create paddle. We have to say how big it is, right? So let's say 30 by 100. And we have to say what is the position of this paddle, right? So we have to say CG point make it's complaining. Where do we want to place it? Well, let's say we'll place it 10 points from the edge. And we'll place it self.frame.mid-y. The middle of the screen. And we have to add labels, right, with position. So we created an object. If I run it right now, I won't see it because it's not added to the scene. So I have to say self.addChild paddle. I have to add this exclamation mark at the end because this is optional, right? But I know there is a value because I just created it. Now if I run it, I should see my paddle somewhere. Why we don't see it? Paddle position. Let's try this for the beginning. That's my paddle in the center of the screen. Now, if playing Pong, probably you don't want this to be in the portrait mode. We'd probably prefer the landscape. How can we change that? You remember, you select the root of your project. You can modify the position, the orientation of the device that you allow for this application. Right? So for example, you can disable the portrait mode for your application, for your game. And then the only thing that remains is a landscape left and landscape right. Now if I run this, each turn, right? It's in the landscape mode. Okay, going back to the scene. Creating the paddle. Probably we should do this, right? The height should be 100. The width should be 30. Now the position, right now, we can do this. Right, 10 and mid Y. It should position it more or less where we want it. Maybe too close to the edge. Let's try this. Why are you complaining? Because we didn't unwrap. That's better, right? So it's 10 points plus half of the width, because the origin, the midpoint of this paddle is the origin, right? The position is calculated for the center of the sprite. So we have the first paddle. The second paddle we can create in exactly the same way, right? Self dot paddle 2 equals create paddle. Same height, same width, different position. Point, make. What will be the position? Position will be self dot frame dot max x. It's the other edge of the screen minus ten plus 15. The Y in this case should be exactly the same, so it should be self dot frame dot mid Y. Again, we have to add child, so we have to add paddle 2. Run and test. We have 2 paddles. So finally, we need a ball. And the ball, we can create with shape node, another type of node that you can use. Very flexible in terms of drawing, because it allows you not only to draw rectangles and circles, but any kind of path that you want. So I will create a function, func create ball. this function will return escape shape node. We'll take two parameters. The first one will be radius, CG float, and the second one will be position, CG point. All equals SK a shape node. Now we have lots of options to choose from. The first one is circle of radius. Let's select this one. We have the radius. We have the ball. Now for this ball, we can set fill color, orange. We can also set what? We can also set the position. So it doesn't. Return B. Now self dot ball equals create ball radius, let's say 20, and the position will be CG point dot, sorry, CG point self dot frame dot x self dot frame dot y. And again, self add child ball. So now we have all three of them. How can we make them move? What should we do to make them alive? Remember the lecture, you move sprites with actions or you use force, right? Use physics. Let's start with actions. Let's say I want to move paddle 1 in a way that it follows my finger, right? So if I swipe on the screen, I want the paddle to follow my finger in the Y position, right? In the Y-axis. How do I do that? Well, first I have to override method touches began. That's for start, right? And again, we will do the same trick that we did in the UI kit. So first we will check if we have a touch. Touch equal touches dot first. Get a touch. What do we do with this? Well, we can get the position of the touch within the whole screen, right? In the big frame that we are using. Let position equals touch dot location in node. Now we have to say within which node. Well, self within the scene. We have the position. Now we can create an action that will move our node. So action move will be equal to sk action move to, we don't want to modify x, we just want to move up and down, right? So we can use move to y. We can say position dot y, that's where we want to go. Then we have to say how quickly. Let's say 0.1. That should give us a pretty quick movement. Forget about let and var. And how do we execute this? We say that the paddle 1 should run this action. If we leave it like that, we'll have to tap, right? That's not exactly what will be the most comfortable. So really we should add also override func touches moved and basically use the same code. And now we don't have to tap. We can also swipe, and the paddle will follow our movement. Okay, let's run. There is a slight delay, but it's moving. Now, if we want to use force, if we want to use physics, because we could move ball in exactly the same way. Do we want to do that? Not necessarily, right? We want ball to be more independent, right? And we want ball to follow the physics. What do we need to do? We need to add to all elements that we have right now. We need to add physics body. If you remember Unity, you have rigid body, right? That was the element, the component of the game object that was really turning it into a physical object. In SpriteKit, it's called physical body. So what we'll do right now, we'll add to all elements that we created, we'll add physical bodies. So to paddle and also to the ball. Paddle dot physics body equals sk physics body. Again, we have different options, right? Starting from circle through some rectangles and such. What we want to use rectangle of size. We know what is the size of our rectangle, right? We have width and height. We can create CD size. With same thing for the ball, right? You can say B dot physics body equals SK physics body. Now I can choose the circle, right? I can say circle of radius. I know what is the radius. If I run it right now, what will happen? It will fall. That's not the behavior I want. So what I have to do, I have to disable gravity. Right? I have to say that the physics body for B affected by gravity equals false. And same thing for paddle. Paddle dot physics body dot affected by gravity equals false. Okay, that's more like it. They don't fall. How can I move the ball? Well, for example, in touches began, I cannot force. Well, I want to do it only once when we start the game, so I will create a variable flag that I will switch, right? So with the first touches began, if start, then I want to do two things. First, start equals false, so I cannot go there the second time, and then ball dot physics body dot apply impulse. CD vector, let's say 10, 0. So what we are doing, we're pushing the ball along X with a force of 10 units, and it's just an impulse. What is the difference? There are two types of methods. It's apply force or apply impulse. What is the difference between these two?
Force is constant, impulse is once.
Yes, exactly. Force is pushing the body constantly, and impulse is one-time event. If you have whatever damping field, friction, this force applied as an impulse will gradually dissipate, right? So the body will slow down gradually. And that's what we're gonna see right now. I'm applying the force, and it's getting slower and slower and slower. Well, it's also pushing my paddle out of the view, but it's gradually slowing down. Again, this is not what I want. So I have to modify more parameters. I have to say that the ball physics body dot friction is equal 0. That the physics body linear damping is equal 0. That angular damping is also equal 0. Physics body dot restitution, so how much force is retained, is equal 1. You can also set mass. Physics body dot mass. Now let's say if we make our ball very light, say I will set mass to 1, but at the same time I will copy paste this code because that's exactly what we want for a paddle. If I say set the mass of the paddle to be way bigger, the paddle will be way heavier, what will be the result? If I play, well, first I have to modify this, either the mass of the paddle, set it even smaller, or I have to increase the force. Virtually don't. It's not pushing the paddle anymore, right? Let's add more force. Let's make it even lighter. Now it's away. And now it's bouncing back and forth. But if we move our paddle, or if it bounces on the angle, it will go away. Right? Do we want to have this? Maybe, maybe not. How can we somehow build edges to our field? We can use another physics body, and we can add this physics body to the frame. So we can say self dot physics body equals sk physics body. There is rectangle, sorry, edge loop from rect, edge loop from rectangle. What is the rectangle? It's the frame. Self dot frame. Play it now. It will bounce from the edges. Let's do one more thing. The second paddle is static right now. Let's add some intelligence to it. It will follow the ball. As we said, place where we should do it is here on the bottom, right? It is update function. What can we do? We can associate the position of the paddle with the position of the ball, right? So we can create again that move action equals sk action dot move to y, or y is defined by the ball dot position dot y. Duration, well, we can make it faster, we can make it slower. Let's say 0.2 will be the duration. Will be a little bit slow. Of course. And then paddle 2 dot run action move action. I will have something that is a little bit more dynamic. Now, during the lecture, we'll talk more about collisions and how we can recognize what we can do with collisions, how we can ignore certain things and collide with others using masks. That's for next week. We'll finish at that point, and for the rest of the class, you